record this. Okay. Cosecant and sine, we know those are reciprocals. I want you to think about an alternative form under the reciprocal identities. If we were to multiply cosecant of x times the sine of x, what's that going to be equal to? Careful. If we take a number and we multiply it times its reciprocal, what are we going to get? 1. Yep. We get 1. So the cosecant of x times the sine of x is equal to 1. That's kind of an alternative form of these identities, those two identities. If we multiply the cosine of x times the secant of x, that is also because they are reciprocals of each other. That's what it means to be, part of what it means to be reciprocals, right? Is that we multiply them together and we're going to get 1. And then lastly, cotangent of x times, I can't spell. Let me try to write that carefully. Cotangent of x times the tangent of x is equal to 1 also. So those are kind of some alternative forms of the reciprocal identities that I think it's helpful to have on that reference sheet for the next little while when you're looking at those, okay? The quotient identities, you already know these, although you might be thinking sine, y's and r's, but now you just need to extend that a little bit farther. You know tangent is y over x, and you know y is sine, you know x corresponds to the cosine, so it should make sense to you that the tangent of x is equal to the sine of x over the cosine of x. Similarly, you know cotangent is x over y, cotangent of x, the cosine of x is the x, the sine of x is the y, so you get your cosine over your sine, okay? So really it's just these 3 Pythagorean identities that we need to focus our attention on. We're going to do a lot of repetition and a lot of discussion and practice with these because that's what's going to help you get these memorized. Because as I have told you, I promise you, this is not bad as long as you get these identities memorized. If you're going to choose to not take the time to get these identities memorized, this unit's going to be really tough. So the sooner you can get them memorized, the better. In the meantime, not for the quiz, obviously, but in the meantime, anytime we're working on stuff, you should have that reference sheet out and handy and ready to go to help you out. Okay? So that first Pythagorean identity, Claire, can you read that one out for me, please?
Sine squared x plus cosine squared x equals 1.
Sine squared x plus cosine squared x equals 1. It doesn't matter if you use x, theta, beta, lambda, q, whatever. So sine squared theta plus cosine squared theta equals 1. Guys, guess what? It's addition, so it's commutative. So cosine squared x plus sine squared x equals 1 also, obviously, right? Okay, so that's the first identity. Okay, Claire, what does that say again?
Sine squared x plus cosine squared x is 1.
Okay, so that's the first one. That's really kind of the main identity. The other 2 Pythagorean identities, you basically can derive them from this first one. I'm not going to show you how. If you want to see how that's done, you can come and see me and I'll talk to you about that independently. You can derive these other 2 by a process by knowing that first one. So some people just focus their attention on the first one, but I think it's helpful to memorize these other 2 as well. Okay, Claire, read that first one again for me, please, because then we're going to look at these others.
Sine squared x plus cosine squared x equals 1.
Equals 1. Okay, that's the first one. Maddie, can you read that second one for me, please?
1 plus tan squared x equals secant squared x.
Okay, so 1 plus tangent squared x equals secant squared x. That one seems a little bit stranger. What I want you to think about and what I want you to notice between the second identity and the third identity is there's kind of a connection there with them. So if you can memorize the second one, which says what, Maddie?
1 plus tangent squared x equals secant squared x.
Okay, so if you can memorize that one, 1 plus tangent squared x equals secant squared x. If you can get that one memorized, The other one kind of falls into place because the only difference is that we're adding co in front of each of the trig functions. So Sheridan, can you read that last one for me, please?
Yes, 1 plus cotangent squared x equals cosecant squared x.
Okay, so do me a favor, hold that thought for a second. Okay, Maddie, do me a favor, read yours again.
1 plus tan squared x equals secant squared x.
Okay, now listen to Sheridan's and think about the connection. The only difference is that Sheridan's has co in front of each of the trig functions compared to what Maddie just read. So Sheridan, can you read that one out again?
1 plus cotangent squared x equals cosecant squared x.
Cosecant squared x. So 1 plus tangent squared x equals secant squared x. 1 plus cotangent squared x equals cosecant squared x. So really, they're very similar. You kind of just need to memorize the one, and then the other one kind of falls into place, I think, in my opinion. Okay? All right, there are kind of some alternate forms of these that we should look at as well. So besides thinking of this as sine squared x plus cosine squared x equals 1, we could isolate the sine squared and get the sine squared by itself. That's the word I was looking for, isolate. If I wanted to know about just sine squared, I could subtract and move that cosine squared over to the other side. So an alternative form for this sine squared x plus cosine squared x equals 1 would be sine squared is equal to 1 minus cosine squared x. And then similarly, we could isolate just the cosine squared x, and we would have 1 minus sine squared x. So those are some alternative forms. I don't think you need to memorize those, but you should be somewhat familiar with them, and I promise you, you are going to see those, and you're going to want to be able to make that connection of, oh, when I see 1 minus sine squared x, I can replace it with cosine squared x because they're equivalent. Okay? So those are alternative forms. Similarly, we could come up with some alternative forms for these as well. I could isolate and keep that tan squared by itself. So that's going to give me secant squared x minus 1. I could just get the 1 by itself, right? And that would be secant squared x minus tan squared x. And we could replace that with just 1. All right, so those are alternative forms for that second identity. So similarly, because these are so similar, we could do the same type of alternative form of this last set of identities as well. So 1 is equal to cosecant squared x minus cotangent squared x. All right. All right, questions, comments on those? Okay. All right. I promise this stuff is not bad, but you do have to get these memorized. So you got to kind of start working on that, okay? Please, please, please. All right, what we are going to look at today, what we're going to do in general with these, it's kind of a logical thinking process, steps involved here. Similar, not exactly the same idea, but a similar idea is, if you remember when you, back in your geometry days when you were solving and doing proofs, it's kind of a similar logical steps, logical process. In my opinion, it's easier, but part of that boils down to, have you gotten your identities memorized? So anyway, so we will get to that. That's what we're going to look at tomorrow. For today, we are going to do something we're going to use these identities. It's kind of more of a mathematical process, so it's nice to actually have a little bit of like math and numbers in here with this. So the problems we're going to look at today actually involve a little bit more math per se and numbers as opposed to kind of all of just the different trig functions. Okay? Before we move on though, Claire, what's the first identity?
sine squared x plus cosine squared x equals 1.
I was hoping you weren't going to have to look at your paper to do it, but that's okay. We'll get there. Maddie, what's yours?
1 plus tangent squared x equals secant squared x.
Secant squared, yes. Okay, and Sheridan?
1 plus cotangent squared x equals cosecant.
Okay, all right. Awesome. Okay. Claire had to repeat hers a few more times than Maddie and Sheridan, so that's why I was hoping you might have it memorized by then. But you'll have it memorized before the end of the class period. And hopefully most of the rest of you will also. All right, let's look at a couple of examples here. So if you notice, it's just saying apply the reciprocal identities, the directions here. So that should give you a hint about some things. So this first example in particular, if the cosine of theta is equal to 3 over 4, then what is the secant of theta equal to? 4 over 3. We just have to flip it. Exactly. Right? If we know the cosine value, then to find the secant value, all we have to do is flip it. Okay? If the secant of x is equal to 5 over 4 and the tangent of x is equal to 3 over 4, we need to figure out what the sine of x is equal to. There's actually kind of a few different ways to kind of think through this. But specifically to use reciprocals and kind of our quotient identity also. If we know that the secant of x is equal to 5 over 4, then what's the cosine of x equal to? Ethan, what's the cosine of x? 4 over 5. There you go. So cosine of x is 4 over 5. What do we know? Let's think back to our quotient identity about tangent. We know that the tangent of x is equal to the sine of x over the cosine of x. So we can actually plug in some numbers from here, right? Or actually at this step, even before we do that, we're trying to figure out what the sine of x is equal to. So to get the sine of x by itself here, if you think about it, what we would have to do in order to solve, we could multiply both sides by the cosine of x and multiply by the cosine of x. Whoops. And so we get that the sine of x is equal to the cosine of x times the tangent of x. So let's plug in those values and just figure out what the sine of x is equal to. So that means that the sine of x has to be equal to, we know our cosine value is 4 over 5. We know our tangent value is 3 over 4. So what happens there? 4's divide out, what are we left with? Sine of x is equal to 3 over 5, 3/5. You got it.
Okay.
Carly.
Would I have to do it like that on like a test? Because when I looked at this problem, I just saw, I knew what tan was, I knew what cosine was, and then I just took the numbers from there. Could you just do it like that, or do you have to?
I would want to see at least a little bit of math, so I would want to see like how you are doing your figuring there. But yeah, if you see another way of doing that, as long as it's showing me some math, I'd be okay with that. All right. What about this last one? We're supposed to figure out what tangent of beta is, and we're given cosecant of beta and secant of beta. So what do you think, guys? Claire?
I would change the cosecant and secant to sine cosine.
Okay, so cosecant of beta, let's flip that. So sine of beta is 7 over 25. And I think what you were saying is take this and we can flip that also when we get cosine of beta is 24 over 25. And what's our ratio for tangent?
Sine over, right? Or cosine?
Sine over cosine. So that means we have 7 over 25 over 24 over 25, and that simplifies to just 7/24. I didn't do the process of writing out that keep it, change it, flip it. If you need to write that step to see that you get the 7/24, please do that. Oops, I'm throwing my pencil around, sorry. Okay, all right, questions on those? Okay, it's gonna get a little bit more complicated here, but not much. Okay, for what it's worth, we're gonna look at these first two. We're not gonna work through the bottom two entirely. They're very similar problems, but, so we don't need to work through them all completely, but there are kind of a couple little things that I wanna point out to you about the way they are set up and written in these last two examples as opposed to these first two examples. Okay? All right, so if you notice, it's giving us a cotangent value. It's telling us information to help us decide which quadrant we're in. Why would we need to know what quadrant we're in? Okay, decide what's positive, what's negative. There you go. So we need to figure out and decide what quadrant this is telling us we're in, because that's going to help us decide on signs. And it's saying we need to find all 6 trig functions. So let's go ahead and write that out, like now. So sine of x, cosine x, okay, and it gave us one value. It told us that cotangent of x is 3/4. So if this is 3/4, then we know tangent is 4/3. So we have that written in already. For me personally, I tend to forget about dealing with the positive and the negative signs. So for me, I like to kind of deal with that first and get it done and out of the way so that it's not hanging over me and I don't forget. So if we are in the interval from pi to 3 pi over 2, so if you need to go back and look at that unit circle and think about where pi and 3 pi over 2 are, that's telling us a specific quadrant. What quadrant is that? 3. Were you going to tell me that, or did you have a question? Oh, okay. All right, so we're in quadrant 3. So let's think about what that means. Quadrant 3, in quadrant 3, we know that tangent values and cotangent values are positive. We know that these are all negative. And we know this because of you need to write that out to help you think about what quadrant you need to be in. Someone in my first period class was like, oh my gosh, that was so long ago. We have to remember that still? Yes, you do. You have not been, as Mrs. Crott likes to say, I have not given you permission to forget anything that you've learned. Okay. We're given what cotangent is equal to. We need to use our Pythagorean identities. Up until now, if you had seen a problem like this, from here we would draw a triangle and we would use Pythagorean theorem and we would use SOHCAHTOA. Now that we have Pythagorean identities, we want to use those Pythagorean identities. So I want you to take a look at those Pythagorean identities. I want you to think about the fact that we know something about cotangent, which then also means we know something about tangent. So there's a couple of different identities that we could choose to plug into to find, because think about what we have to find. We have to find sine and cosine and cosecant and secant. So what Pythagorean identity can we use that relates to cotangent?
1 plus cotangent squared x equals cosecant squared.
Okay, so 1 plus cotangent squared x equals cosecant squared x. That's Sheridan's identity. Right? Okay, so we're going to plug in what we know in the math here. So 1 plus, we've got to square that 3/4. So you square numerator, square denominator. So 3 squared is 9, 4 squared is 16, and that's going to be equal to cosecant squared x. We need to be able to add these fractions, which means we need common denominator. So I'm going to rewrite that 1 with the common denominator. I'm going to rewrite that as 16 over 16, because that's equivalent to 1, right? And that's common denominator. So now if we add that together, we get 25 over 16 equals cosecant squared x. So from there, if we take the square root of both sides, we get that the cosecant of x, square root of 25 is 5, square root of 16 is 4. So the cosecant of x is 5 over 4. And we've already decided that this has to be negative, so we don't have to worry about those signs. We already put those in. And that means that our sign value is 4 over 5. All right, we're getting there. We're not quite done. These are a little involved. Now we need to figure out what cosine and secant are. So we have a few options. We could use our ratios like we did earlier with our tangent and sine and cosine. I would prefer that you practice with these identities though. So somehow we need to find our cosine value or our secant value. And I can think of 2 different ways that we could go about doing that. What do you think, guys?
1 plus tangent squared x equals secant squared x.
Okay, Ethan says let's go with the 1 plus tangent squared equals secant squared. I like that. Okay, so 1 plus tan squared x equals secant squared x. That's Maddie's identity, right? I think. Yep. And we're just going to use the reciprocal of this. So we're going to say 1 plus, we've got to square that 4 thirds. So 4 squared is 16 over 3 squared is 9 equals secant squared x. We need common denominator, so I'm going to rewrite this as 9 over 9. So if secant squared x is 25 over 9, then secant x is 5 over 3. And that means cosine is 3 over 5, and we already dealt with our sines, so we're good to go. Voila, you have just solved your first problem of that type. All right, Ethan suggested that we use this 1 plus tangent squared x equals secant squared x, and I want you to think about the fact that because we solved for cosecant, we also knew our sine value, so we also could have used sine squared x plus cosine squared x equals 1 and figured out what cosine was and then gone back and gotten the secant. So that was the other way that I was thinking of that we could have solved this one. Okay? Does that kind of make sense, I hope? All right, questions on this? Sky?
We're not allowed to find them by just like looking. It's opposite and adjacent hypotenuse.
Correct, because you are not supposed to be thinking triangles. And it's easier when you have these nice pretty numbers that you're familiar with, like a triple. They're not always going to be that pretty. Okay? Yeah, good question though. I'm going to want to see the math for this, for sure, okay? Showing me that you know how to use these identities. All right. Good question though, I'm glad you asked. Okay, let's try this second one here. Oops, well, let's go ahead and do this first thing, because we know we're going to have to find our sine of x and cosine of x and tan of x. Okay, we are somewhere between pi over 2 and pi, so what quadrant is that?
2.
Okay, that's quadrant 2, sounds right. So in quadrant 2, I know that sine and its reciprocal is positive, and cosine and its reciprocal, and tan and its reciprocal are all negative. Okay?
The quadrant is from the unit circle.
Yes, quadrants are from the unit circle, so from pi over 2 to pi is a, right? Okay. All right, we are given tangent. Yeah, so let's go ahead and then plug in those values. Why wouldn't we want to do that? -1/2, and then this would be -2 or -2 over 1. Roman?
How do you know what's positive?
In quadrant 2, remember in quadrant 2, this is telling us that, whoops, I thought I was in highlighter mode. Let me try that again. In quadrant 2, we know that sign values are positive, and that means that the other two are negative. So cosine and tangent are negative. Okay? So yeah, write this out if you need to. That all students take calculus to help you with that. This is telling you where the different trig functions are positive. So remember, all of them are positive in 1, sine's positive in 2, tangent's positive in 3, and cosine's positive in 4. Okay. We are given a tangent value. So what trig function should we, what Pythagorean identity, I guess I should be more specific. What Pythagorean identity should we use?
1 plus tan squared x equals secant squared x.
Okay, sounds good. So 1 plus tangent squared x equals secant squared x. Oops, all right, Ireland. 1 plus tan squared x equals secant squared x. And we're gonna plug in, so 1 plus tangent is -1/2. If we square that, we get positive 1/4, and that's equal to secant squared x. Here's where kind of adjusting that fraction is gonna help you. So we want common denominator, so let's rewrite that 1 as 4 over 4. So we get that secant squared x is equal to 5 over 4. So that means that secant of x is equal to the square root of 5 over 2. Okay.
Why is it not negative?
Well, okay, here's the deal. I didn't really talk about this, but when you take the square root of both sides to solve, you do have to consider the positive or the negative. So that's why we had to decide on the quadrant. So in this case, it is actually negative, but I've already put those signs in there, so I didn't have to stop and think about it. At that point, it's already kind of written in there and filled in for me. So overall, the overall value is negative. Does that answer your question?
No. Because when it's 1 plus 1 over 4, shouldn't it be 1 minus 1/2, and then
Okay, we're squaring though. So if we square,
yeah.
-1/2, that's what you were asking. Why isn't that negative? A negative times a negative is going to give us the positive, right? Roman?
Is tan squared x equal to 4?
Tan squared x is equal to positive 1/4, yes. Okay, so secant is equal to negative square root of 5 over 2. So if we flip this, if we do -2 over the square root of 5, we've got to rationalize that. So we get -2 root 5 over 5. All right, and now we've got, we've got those bottom 4 trig functions. We need to know what sine and cosecant are equal to. So we've got to decide what trig function to use here. I want to use which identity, I keep saying which trig function, which identity we want to use. I want to use the sine squared x plus cosine squared x equals 1, because I want you to see a little bit of a math trick with this. Ethan, you had a question?
I was gonna ask to go to the bathroom.
Yeah, hold that thought. Hold on. All right, let's use sine squared x plus cosine squared x equals 1 as the identity that we're going to use to solve from here. And we know that cosine, guys, here's the beauty of this. I'm going to use, as my cosine value, I'm going to use this -2 over the square root of 5, because I'm about to square that, and so that's going to get rid of the radical. So you don't have to use this rationalized form. Use this original form here. That's kind of what I wanted you to notice. If we use that -2 over the square root of 5, it's going to work out just fine, because -2 squared is 4, and the square root of 5 squared gives us 5. So we get sine squared x plus 4 over 5 is equal to, in this case, I'm going to switch that to 5 over 5, so I have my common denominator, because I'm about to move that 4 over 5, I'm about to subtract that over to the other side, and so I get sine squared x equals 1 over 5, and when I take the square root, I get sine of x equals, the square root of 1 is just 1, and we get the square root of 5, and then we've got to rationalize that. So sine of x is root 5 over 5. The cosecant, is just going to be the square root of 5. Or the square root of 5 over 1. Okay. Roman.
The square root.
I'm sorry?
Because you put sine squared x equals 1/5, you put it equals 1 over the square root of 5.
Yes, if I take the square root of both sides here, if I square root this, then I'm just going to get sine x. If I square root this, the square root of 1 is 1, the square root of 5 is the square root of 5. Okay? It starts to get messy. That's why I don't like to write that step, and maybe I should, because I think it would help you. I think some of you guys kind of get lost in that because I'm not showing that step, but it starts to get so messy when I do that. That's what I tend to not. All right, what do you think? Tedious, quite a bit of work. It's not hard, it's just that there's a lot there, I think. It just takes practice. Okay? I just want to kind of point out a couple of things about these next two examples. If you look at them, you look at the actual problems, they are very similar to the two that we just did. So I'm not going to work through them in their entirety. I just want to show you, I want you to think about this because part of it is it's kind of written in a little bit different format. This is saying that cotangent is positive and cosine is negative. So you've got to think about which quadrant that is. And once again, that is quadrant 3. No, they're not all in quadrant 3. It just seems that way. But I want you to notice something else also. In this example, it's not telling you to find all of the different trig functions. It's telling you to find some specific ones. It's only telling you to find the sine of theta and the cosine of theta. So you may want to spend a little bit more time kind of thinking about, okay, what's the best or easiest way for me to get from what I'm given to what I'm trying to get to, right? So I have a cotangent value and I need to get sine and cosine. So I'm probably not going to want to think of that as cotangent because that's, well, I could. Actually, either way. To go from cotangent, I could think cosecant and then flip. So 1 plus cotangent squared theta equals cosecant squared theta. And then take the reciprocal of my answer, and that would give me my sign. And then from there, we could either use the sine squared x plus cosine squared x equals 1, or we could go back and flip this and think of this as tan theta as being a half 1 plus tangent squared theta equals secant squared theta, and then we could take the reciprocal of that answer. Okay? So that's all. Like, if you feel like you want or need to do a little bit more practice along the way at some point, we're not going to work through these. I just wanted you to kind of think through and talk through what you've got to do in order to kind of work to that next step. That's the process that I want you to think about. Okay? All right. We're going to take a break from this. I want you to think about your identities. I need you to flip to page 3 and fill in the blanks. We're going to go over this here shortly. And I will explain. While you're working on this, I'm going to hand out the homework worksheet for you so you can kind of see, and I'll explain a little bit more about that, okay?